Okay, we will talk about data architecture in this lecture. This is the part of information architecture. The first part, the second part, we will talk about application architecture. So in this lecture, I will share to all of you how to define data architecture, the context of enterprise architecture. Because information architecture is the phase after the business architecture. So the artifacts we have resulted from the business architecture will be used in these steps to define a data architecture. So we will talk about the input, step, and output for defining data architectures, and also the core artifacts in data architecture. So data architecture is the critical architecture in enterprise architecture. And based on my previous experience on evaluating and also assessing enterprise architecture uh, in in academic projects and also in real world implementation of enterprise architecture, the biggest architecture in enterprise architecture is data architecture. So it's a very important to define the good data architecture representing the business requirements. So if in the previous lecture we talk about the business architecture, we have defined it as example business process decomposition or function decomposition. So the big question is what what is the data architecture for supporting that business architecture. So in this part of lecture, I will talk to you about the artifacts, the philosophy behind the artifacts of data architectures, and how to define that architecture uh, as a as a core artifacts in enterprise architecture. So this is the overview of artifacts. The overview of artifacts. So if we talk about data architecture, so the first part is the scope of data. The scope of data. The scope of data will be represented by data entity or data component catalog. So this is the list. This is the list representing the scope of data in enterprise architecture. So as example, if we talk about academic enterprise architecture, as example like in Telkom University, we will talk about the range, the spectrum, the scope of data entities supporting academic end-to-end business processes. And the second is about the relationship of data to business. This is data entity and business function is the relationship data to business function. And the second, the relationship of data to applications. So example, example, if we have 100 data entities in our enterprise architecture, so we have to define the matrix between data to applications. So this matrix will describe what information or what data processed by each application in our application architectures. And this is the core of data architecture. The first is the scope, and the second is the relationship to business and application. And the next is the additional design of our data architecture. So, example, we have to define entity relationship diagram in conceptual and logical, and also we have to define the distribution of our data in what applications. Example, if we have 100 data entries in our data architecture, so the distribution of data will be shown in the data dissemination diagram. So actually, data definition diagram is a sim with is similar with application or data matrix. Similar with application or data matrix. Okay, and data security diagram, migration lifecycle is an additional diagram we can use for representing our data architecture. But if we have, in my opinion, in my personal opinion, data migration diagram is very important, especially if we want to migrate one application to other application. So in this case, we have to define the data migration diagram, because maybe we have to handle the conversion of data from legacy systems to the 2B to the 2B architecture. Example, okay, we have for academic information system we have 5 application right now, so we have to move to one application, integrated application. So we have to convert 5 physical database to one physical database. This is the example of the example usage of data migration diagram. Okay. And the next is maybe in the next session will be in application architecture. We talk about application architecture, but in this opportunity, I will focus only in data architecture. Okay, this is the input step output. But the input is the artifact from business architecture. Okay, capability assessment is from business architecture. Organization model is from business architecture, and also the principles is artifact defined at preliminary and visions. Statement of architecture work is the description of our scope of work or for developing enterprise architecture vision. So the first is we have to select reference model of viewpoint. Example, reference model like this. Oh, okay. Example, we have to define the data architecture for academic function. Okay, so we can refer to the other academic information system. Maybe if we want to develop a data architecture for Telkom University, so we can use as a reference architecture data architecture from ITB, from Universitas Indonesia, UGM, and so on. And also the viewpoint. So we have to define the viewpoint in the perspective of developer, in the perspective of academic director, in the perspective of students, in the perspective of IS department. So this is the first step. The next step is to define the baseline. The baseline architecture implemented in existing application architecture. And the next is to develop the target architecture. So this target architecture, we have to consider not only the data requirement, but also the next design of application architecture. Okay. Example, if we want to migrate 5 existing applications to one application, so we have to add in our artifact in data architecture data migration diagram. Okay. But if we develop the new enterprise architecture and we have no application before, so this is a very new application, and this is the from scratch is the new application information system. So that's why we didn't need to define the baseline. We didn't need to define the data migration diagram because we only want to develop new applications, and there is no no existing or legacy system. And from the baseline and target, we will have to develop the gap analysis, and we will define the roadmap, and conduct a formal stakeholder review. So our decision must be presented like a sample to IS division, head of IS divisions, or maybe to solution architect, or maybe to enterprise architect. So we have to explain our artifacts to them. So based on our explanation, maybe they will review our design, our proposal, and make a recommendation and approval and final approval of our recommendation. Okay. Okay, this is the artifacts as I explained it before, the catalog, metric, and diagram. Okay, the catalog is the scope. The matrix is the relationship between the data to application and between the data to business function. And diagram is additional artifacts. But if you ask me what the core artifact for diagram is, entity relationship diagram. Entity relationship diagram. Okay, this is the diagram representing the relationship between table to tables. Table here is similar with data entity. Okay, so one data entity can be represented using table in entity relationship diagram. And the additional diagram, this is the optional we can use, is like data migration diagram, as I explained it before. Okay, data entity. So the first is data entity or business function matrix. So for every business function, we have to define data requirement. Second is system data matrix. For each applications, we have to define data entities. We have to define related data entities. And maybe for additional, we can define the class diagram. The class diagram, also data dissemination diagram. But in my opinion, the critical artifacts of data architecture is data entity, business function matrix, and system data matrix. And maybe we only need to define entity relationship diagram, not class diagram. Maybe that artifact is useful enough to define the application architecture, maybe. But if we talk about the object-oriented programming, web service-based application development, so we have to not only define entity relationship diagram, but also the class diagram. Okay, if we have defined the system data matrix, it's optional. We define the data dissemination diagram because data dissemination diagram is similar with system data matrix. Matrix and diagram is only different view of something. So if we have defined the relationship between data and application using system data matrix, so we don't need to represent it using data dissemination diagram. And this is the example. Sorry, not the example. This is I want to talk to you about the two kinds of data. The first is data master, and the second is data transaction. Okay, the master data is the data that will be used by several or so many business functions. This is the data master. Example like students. Students in Telkom University Enterprise Architecture is the example of data master. But you take one student's class is data master, because student will be used like example in every steps in academic functions, and class will be used also in a room, class, lecturer is the example of data master. But what is the meaning of data transaction? Data transaction is the relationship between the master. Example, the scheduling of lecture. So this is the relationship between the lecture, the room, and the timetable. Okay. So this is the example of data master and data transaction. Data transaction and data master. Okay, this is the example of data entity business function matrix. Okay, business partner. Okay, so this is the example of business function, and this is the data entity. Example, the relationship between the customer CRM to customer master data, business partner data, manage for service for business partner data, also the owner, sales and marketing business unit executive. This is the example of customer master data, and also maybe the function. The function can create, read, update, delete, or customer master data. This is the so for customer relationship management, in the simple explanation, so we will need the customer master data. Okay, the customer data. This is the master data, the example of master data. In the context of customer relationship management, we will need it. We will need the customer master data to define the business service. And customer relationship management, customer CRM, customer relationship management can create, read, update, or delete customer master data. So in this representation, customer master data only created by customer relationship management, only created by this function. Okay. This is the example of system data matrix. This is the application. This is the data. Okay. Okay. CRM will be mapped to the customer data. Commerce engine will use sales orders. This is the example of master data. Okay, sales orders is the example of transactional data, because sales order is a relationship of customer data and product and buying activities. Okay, this is the example of system and data matrix, and this is the example of ERD. Class diagram, ERD and class diagram. I think all of you have been studied this section in the previous lecture, maybe in application analysis and design, maybe application analysis. And so the basic capabilities of data architecture is how to define entity relationship diagram. And this is the example of dissemination. So, example, we have two kinds of applications. The first is warehouse management, and the second is billing management. In warehouse management, we will find customer, order history, and stock. But in billing, we will find customer account balance and invoice history. This is the example of mapping of data to applications. And the big question is how to define the data entity, to define the data entity, the scope of data architecture in for our information system architecture. So this is the additional slide I add personally because this is very important. So I suggest you back to the artifacts of business process decomposition from business function decomposition. So for each function as a result of business process decomposition or business function decomposition, I suggest you to identify the data input and data output. Data input and data output. So this is the example. Okay, for inbound logistic, we have several. We can make a decomposition. Example: material procurement, warehousing, shipping or tracking. So, but in this case, we only discuss about the material procurement. So, imagine that this is one company produce, example, one product manufacture, example like cars or motorcycles. Okay, so for inbound logistic, this company must make material procurement. So imagine that what data the company will need to accomplish procurement activities. For example, for data input, we have to define, oh, okay, we will buy the material from vendor, so that's why we will need vendor data. Second is the raw material itself, okay, the raw material itself. So we have to define if we want to buy this material, so we have to contact what vendors. This is the vendor and raw materials. And the data output, we have to imagine that after we make a deal with the vendor, so the vendor must send their material to our warehouse using tracking service. Okay, using a tracking service. So that's why we will need the tracking activities. Okay, sorry. The first is procurement deal, and the second is tracking activities, and the third is warehouse because we want to send material from the vendor to our warehouse. So that's why for data output we will have tracking activities, warehouse, and procurement. Okay, so this is the raw analysis of data entity scopes, and after we define the long list of data entities, so we have to process further to define the entity relationship diagram. So, but the weakest link in data architecture definition is defining the scope of data entities. The analysis based on the business function decomposition will be very useful to define the scope of data entities. This is only one example of sub business processes. Okay, so if you have example 5 business processes, and for each business processes there are example 5 sub processes, so we have to define 25 sub business processes, 25 analysis using approach like this. Okay, this is the simple method we can use to define the data entities for each sub business processes of business process. Okay, thank you for your attention. We will continue in the next session in application architecture. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.